Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty, who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which is really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Uh, Good evening, everyone. Please confirm me if my voice is audible and screen is visible for you. You can confirm in the chat box. Okay, right. Thank you. Thank you. Okay, right. Fine. So in today's session, welcome back. So uh, till last session, we discussed about a module or a development board, which is nothing but an Arduino. And in today's session, we I am going to introduce one more module, which is nothing but Node MCU. Okay, so this is a company name from this particular Node MCU, just like Arduino, as we have flavors in this Node MCU also. This is one more company, and this is also having different flavors. So let us discuss and why we choose this particular Node MCU. Okay, and what is the advantages of this Node MCU when compared with Arduino. So everything we'll try to discuss. Okay, and how this particular Node MCU is important for an IoT point of view. Okay, so that is few I mean, let us discuss about that. Okay, so just a second. Right, so let's start with this particular Node MCU development board. Okay, so first of all, let us see what are the difference between this Node MCU and Arduino, and let's have a comparison with it. And basically, let me give you an idea of this particular Node MCU. Uh, this particular Node MCU, it is basically we generally use this more for an IoT applications. Okay, so whenever you say suppose Arduino is there. Okay, so this particular Arduino. So till now we learned something, but we never learned how to transfer or exchange the data to the cloud platform. Okay, so Arduino is 100% a good product or module, but not for an IoT applications. Okay, for an embedded applications, Arduino is the best one when compared with the all other modules. But whenever you want to connect this particular Arduino to cloud platform, it is not that much suitable. Okay, why? Because we learned something, we learned few things from Arduino, but we never heard about the Wi-Fi connections or internet connections because this Arduino board doesn't have that particular internet connections. To get that particular internet connections, again, we need to go for an extra modules. We need to interface that Wi-Fi module or some extra module we need to connect or interface to that Arduino to get that particular internet facilities. But that is little bit complex. Okay, because connecting, because we need to think about the memory and we need to think about the RAM size, etc., etc. There are some other considerations are there which we need to take into considerations. Okay, uh, whether which one is good or not. So Arduino is not a good option when you go for an IoT applications. But Arduino can be used in few applications. If you remember the example which we discussed in the initial stages, like whenever we need to transfer some data from slave device to master device. So say suppose there are few sensors are there, we need to transfer this particular data to master devices using some protocol like Bluetooth, etc., etc. So for that particular purpose, for smaller applications like transferring the data to master device, etc., etc. For that, Arduino is the best one. I can say that. But whenever you want to connect it to a cloud platform to store the data, this Arduino is nothing. Arduino doesn't have that particular features. Then we need to go for an extra one, like we need to buy a shields, we need to interface some Wi-Fi modules, etc., etc. Okay, so this is an overview of why we used to choose a Node MCU than this particular what we say Arduino. Okay, so let us see the comparison with this why Node MCU is a better choice when you compare with Arduino, right? So you can see is one thing is the first and the foremost is the Wi-Fi connectivity. Okay, so this Arduino does not have built-in Wi-Fi. Built-in Wi-Fi is not available in Arduino, but Node MCU, we have a built-in Wi-Fi facilities is there. So in this Node MCU, there are two modules are present like ESP8266 and ASP32. We'll discuss that in the next slides. Okay, so these modules will have this wireless communications are there. So built-in Wi-Fi is available for these IoT applications. This wireless communication is required, but Arduino doesn't have that particular Wi-Fi again, and if to add that particular Wi-Fi capabilities, we need to have an additional hardware, nothing but the Wi-Fi modules, again, which will increase the cost and also the complexity, etc. And the next one is the cost effectiveness. Okay, so when you compare these both, okay, Arduino, it is cheaper when compared with this Arduino because the Arduino, if you want to increase that particular additional capabilities like shields and modules, so the cost will be increased. But all those features with the same Wi-Fi cap mod features, so the same we are having this particular node MCU, right? And compact design, design in the sense whether it is suitable, I mean the size and etc. etc. So this Node MCU is having a microcontroller with Wi-Fi in a single compact board. Okay, so which is very small in size when compared with this Arduino. But this Arduino, whenever you add these extra features or additional functionalities, this Arduino will looks like little bulky. Okay, it's more bulky with less features. So when you compare that particular, when you compare the designing part, so Node MCU will have a good single compact board is there. And coming to the processing power and memory. Okay, as I told you, this Node MCU have two different boards, 8266 and 32. So 8266 having 8 megahertz clock speed and 4 MB of flash memory, and 32 has up to 240 megahertz of clock speed, larger memory, and it also comes with a dual core. Okay, so we'll go in detail of these two modules in our next slides. Just remember that. Okay, but here compared to Arduino, you know the clock speed is only 16 megahertz and 32 KB of flash memory. Okay, so this is a KB and this is of MB. Okay, and then our next comparison is like there are built-in GPIO pins are there. So as I know, as you know, right, GPIO was nothing but general purpose input output pins. Okay, so as this having some general purpose pins, but it is less convenient for an IoT applications. But here, this GPIO pins are can support all the sensors and actuators, and also these GPIO pins having some additional functionalities like PWM, I2C, SPI, UART. There are some additional functionalities are also there, which comes inbuilt with this particular node MCU. Okay, and coming to this ease of use for an IoT development. So this generally this node MCU supports Lua programming language, and also it supports this Arduino IDE which we are using. Okay, and this is Arduino. It is like very versatile. It requires external configurations for that IoT. External configurations in the sense we need to attach some additional boards for this particular connectivity. Energy efficiency. Okay, this the Arduino doesn't have any low power modes are there. Okay, but this Node MCU having that power saving modes are available. Okay, So all these functionalities we'll discuss in the next slides, but just an overview, I'm just giving it. And we have a community and libraries are there. So for both the ends, we have for NodeMCU and Arduino, there is a huge community is available. Okay, for libraries is also available. But for an IoT point of view, Arduino having a little less features. Okay, so we need to require external hardware with the complexity will be increased, etc. for that particular support. So most of the people will suggest you to go to shift to some other module for a better functionalities. For that, everyone will suggest this Node MCU because this Node MCU is having that MQTT, HTTP cloud integration platforms which you can do with this particular Node MCU. So this is the basic difference of Node MCU with this Arduino. Okay, so let us focus on this particular Arduino on how we need to attach this particular Wi-Fi modules to this things Arduino. Okay, so you can see these are the Wi-Fi modules which are available to integrate with this Arduino. So there, those are called as ESP versions. Okay, ESP is nothing but expressive. So these Wi-Fi modules are produced by a company called Expressive Systems. That's why they call it as ESP. So you can see almost 13 different versions of Wi-Fi modules are present here. Okay, so if you in generally for Arduino point of view, we use this ESP01. So this module will be used to get that particular Wi-Fi connectivity to Arduino. Okay, so let's starting different things are there. Let me go by why we call it as an so generally this particular Node MCU company, what they did is they have this particular Wi-Fi chips, and whenever you see if you call a Wi-Fi, you're having some functionalities. So there is having an inbuilt microcontroller is also available for this particular ESP. You can see there is a black color chip is there. This is a microcontroller. Why we need a microcontroller on this particular chip is to for the exchange of data, for the communication with internet, etc., etc. We have this particular chip. Okay, so this chip having an inbuilt like a memory and what we say RAM, everything is there on this particular microcontroller. I told you this is a microcontroller, so definitely they have some good memory, good RAM, etc., etc. Am I right? So using that particular features, they developed a boards, development boards. That boards we call it as a Node MCU boards. Okay, you can see this is one Wi-Fi module. Okay, what they did is they mounted it on a development board. You can see this is a development board, and all the features of this particular Wi-Fi chips will be used using this particular board. Okay, I hope you got it. So they mounted it on a development board, and there are some GPIO pins are available. And just like how you are using your Arduino, in the same way you can use that. Okay, so they're having some USB ports are there. Sorry, like ports are available which you can connect directly to the laptop. Okay, so that is how they develop. So here you can see this is an ESP8266 Wi-Fi module, and total board we call it as a Node MCU board. Okay, understood. And you can see there are some GPIO pins are there, DES, these are the GPIO pins are there. Okay, this is a Wi-Fi. So generally how you are using your Arduino in the same way you can use this Node MCU with some extra features. Okay. So here this is Node MCU company. So it is an open source firmware and a development kit produced for an IoT point of view. But generally it runs with what we say Lua script programming language. Okay. So, but in generally, most of the people will use this Arduino programming language for, to develop, to write some coding part over here. Okay. So, as I told you, this ESP8266 is a Wi-Fi system on chip SoC, which is produced by Expressive Systems. So it is a low cost with full TCP/IP stack. So as you know, right, TCP/IP we already discussed. Nothing but for transferring of data to the cloud platform, we need to follow some fundamental things, rules, so which are nothing but the TCP/IP. So this board will follow that particular things, and it is great for IoT and home automation projects. And it can be used as a silent node device, and UART to Wi-Fi adapter can also be connected. Okay, and this is you can control the inputs and outputs as you are doing with your Arduino, but with having some additional features, which is nothing but the Wi-Fi capabilities. Got it? So here, why it is popular? Because of the low cost. When you compare with Arduino, it is getting a low cost, low power. So Arduino having a 5 volts, but here we are having only 3.3 volts. Okay, and there are sleep modes are also available. Okay, we'll discuss that sleep modes also, and Wi-Fi capability is there, and it is compatible with the Arduino programming language. Okay, and also it is compatible with MicroPython. Okay, and with this ESP8266, there are three different boards are there. One is 12E board and VMON's D1 Mini and ESP01. These are the three boards are available. Okay, so let me show you the comparison. This is a comparison of all these three boards. Okay, it is very small in size. You can see an Arduino, if you clearly see, it is not in the size of a matchstick. Okay, so it having more size is more. Okay, like it's almost the size of a credit card or a debit card size. But you can see these particular boards are even very small than that particular Arduino. Okay, and this is a pin layout of three different things. The GPIOs, you can see GPIOs. These are all the general purpose pins, and also there are some additional features are there also available for that particular things. For the serial communication, you can use all those stuff. Okay, so what can we do with this particular ESP8266? So you can create a web server, whatever the things you can do when you have internet to develop any applications, all those things can be done using this particular ESP8266. So web server, you can create to display the sensor data. You can send HTTP request. You can control outputs, read inputs. Okay, and also interrupts are also available. Data logging projects. You can communicate with the third party services. You can create web applications, and also you can send emails, notifications. You can send data to your WhatsApp. You can Telegram, etc., etc. So these are the few things which you can do while using this 8266. Okay, so this is a board diagram. Okay, let us see some technical data. So here we are using IEEE standard Wi-Fi. So which is nothing but 802.11 support, and TCP support is also there. And as we are using Wi-Fi, there are some modes are available. Wi-Fi modes are available. STA, AP, station, and access point. So we'll discuss these particular modes whenever we are doing this Wi-Fi programming part. Okay. So here you can see there are what we say processor. Okay? I told you right, there is a controller or a processor is available on that particular Wi-Fi, which is nothing but 10 silica extensa 32-bit RISC microprocessor, which is running it at 80 megahertz. Okay. Right, we having a 16 KB of RAM and 96 KB of data RAM, instruction RAM and data RAM. So it is a 10 we having a 10-bit ADC is also available here in this particular process, where you can convert analog values into digital. Okay, and we have a memory 32 KB of instruction catchy RAM and 80 KB of user data RAM. Okay, so external flash support is also there up to 16 MB. That can be achieved by using this serial peripheral interface. Okay, which is nothing but SPI. Okay, so there are peripherals are there, 16 GPIO pins are there, and I told you right there we can use some external serial communications are available. So these are some other peripherals. And I told you right there are power sleep modes are also available. So we will discuss that little later. So just remember there are sleep modes are also available for in this particular boards. And coming to the development boards. Okay, so it is compatible with Arduino IDE, Platform IO, some other environments are also there, and it will support C, C++, MicroPython, Lua programming languages, and also I told you there are wide ranges of boards are available with this 8266 Wi-Fi board. Okay, And these are the development environments where we can use to write a code and dump that particular code. So these are the few other development boards. Okay, so this is an overview what we discussed till now. Okay, so why we need to choose and how do we need to choose? There are different things are there. So as I told you, that there are different boards are available. So which boards you need to use? So you need to think about this USB to UART interface and the voltage regulator circuit. Okay. Boot and reset buttons are available. Pin configuration and the number of pins are there. Size and antenna connectivity is also there. So this is a board which you can see. It is an 8266 12E board, Node MCU board. You can see it is very small in size. Okay, the features are like a 4 MB of flash memory, 11 GPIO pins are available, and one ADC pin are there with 10 bit resolutions. We have an built voltage regulator. So voltage regulator is nothing but which converts like 9 volts or 12 volts or 5 volts into a desirable 3.3 volts. For conversion, we have this particular voltage regulator, and there is a mini USB socket is available to power it or to transfer the data. Okay, so these are the comparisons of these three boards which are available. Okay, so GPIO pins are 4 in a ESP01, and there are 11 in other things. Flash memories, ADCs, size are there. We already seen these things. Okay, so this is a 12E chip, Wi-Fi chip. Okay, with the GPIO pins, and here you can see these are all GPIO pins, and also there are some extra functionalities also available over here. You can use them. Okay, the same this particular Wi-Fi chip is mounted on this particular development board. So all these features are available in this particular development board. Okay, so you can't directly use this particular Wi-Fi because we need to do soldering for this particular what we say pins, etc., etc. To avoid that, we can directly purchase this particular development board. You can see GPIO pins are available over here. You can use this GPIO pins for your programming part. Okay, and there is an normal ADC is also available. Let me explain that. Okay, this is a pin layout for all the things. So as I told you, there are some other functionalities are also available. So you can use that particular functionalities for other function. Okay, so here in this particular boards, I told you right, the operating voltage of this particular board is 3.3 volts, and there are some other power pins are also available. So GPIO pins are there, as you all know. Okay, and these are the remaining features like 17 GPIO. There are some other stuff. So as I told you, there is an ADC is available. 10-bit ADC is there. Okay, so for that you can connect this. There is a pin is available. A0 pin, which is nothing but it's a dedicated analog pins. So what I mean to say is all the digital pins or the GPIO pins which are available are all functions only for digital. Okay, so if suppose if you want to connect any what we say analog sensor like a temperature or a potentiometer, then you need to use this particular what we say uh, A0 pin to program that particular stuff. Got it, guys? So they dedicated pins are available. Okay, A0 pin is available to connect this particular potentiometer or a temperature sensor or any analog sensor uh, to this particular things. Got it, guys? Right. So let us see PWM. So as we already discussed this particular PWMs before, yes or no, even though in our Arduino, we have this particular PWM signals. Can anyone tell me why we use this particular PWM pins? For what purpose? You can pin in the chat box. So we already discussed about this PWM, right? So what purpose we use this particular PWM? You can push your answers in the chat box. Yeah, right. Just to act like an analog pin. So, right. So, let us discuss about this. Okay. So, here we showed, I shown an image like we already seen this, like and connecting an LED. Okay. Say to turn that. So, we saw this in our Arduino programming using this particular PWM. So, we can increase the brightness of that particular. Okay, right. So this particular so coming to this ESP82 doubles node MCU boards also, we have these particular PWM signals are available. Okay, so here these particular GPIO pins generally act as either a 0 volts or a 3.3 volts. Okay, but they can't output any voltages in between. Am I right? So for that particular purpose, to fake that particular mid-level voltages, we use this particular PWM pins. Okay. So which will be just like with that particular fake voltages, um, what happens? The voltages, the range, I mean, the brightness of this particular LED will be trigger. So let us see how this particular PWM will works. Okay. Basically, in general, we have an output like between 5 volts and 0 volts, like a high and low at very high frequencies, right? So here we are using a duty cycles. Okay, so the duty cycle is nothing but the fraction of the time period of that particular LED. Okay, so time period of that particular LED. So you can you see here like we have when maximum voltage and a duty and a period. Okay, so here this is the dotted lines are nothing but the values that you see. Okay, so if you want the 80% of brightness, you need the value which is closer to that particular maximum point. Okay. So it like that you can see the brightness like 20% or 50% or 100% like 0%. So here, so a duty cycle of 50%, which results like 50% of what we say LED brightness. Okay. So zero means nothing but the LED is off fully off. Okay. Right. Duty cycle of 100% is nothing but means that LED is of full brightness. Okay. Got it? So, as you all know, this can be achieved by using what we say analog, right? So, we already seen this programming part. Okay, right? Yes or no? Right. So, analog, right? Pin, comma, pin. So, which pin you are using and what is the value. So, with that particular value, you can vary it. And also, there are some other things are also there. Okay, so using that particular another types also we can vary this particular PWM. Okay, this is an overview. So this is how we can write using that particular duty cycles. Okay, right. This is about the duty cycle PWM pins. Okay, now we'll see the deep sleep modes. Okay, so as I told you, this particular node MCU will have this particular sleep modes. Okay, what is this sleep modes? Can anyone tell me? Can anyone tell me what is sleep mode? We use these sleep modes, right? Whenever we are using our systems, we use these sleep modes. Why we use these sleep modes? You can reply in the chat box. Yes, power saving. Yes. Okay. Right. Say suppose, let me tell you. All right. So we, whenever you are doing a project, Okay, whenever if we made a project with this particular boards like Arduino or ESP troubleshoots. So after dumping the code, if you are deploying it in a real-time applications, you won't connect it to what we say uh, laptop all the time. So for the power, so we need to use any one of these particular power bank or lithium batteries or lipo batteries to give a power to that particular board. Okay, so after some time, what happens? The battery will discharge and it won't long for more time. So what we need to do to save this particular battery is nothing but we use this particular deep sleep modes which are available in this particular Node MCU but not in Arduino. So these particular sleep modes will help the battery to come for longer period of time. So sleep modes or deep sleep modes is nothing but it is saving of power. Okay, if something is happening interesting happening, we'll wake this particular device. Okay, so let us see how to wake how to make these particular sleep modes. Okay, so in generally there are few types of modes are available. Three types of modern sleep, light sleep and deep sleep. So if you want to make this particular uh, device into sleep mode in any one of this particular type. You can see if you kept it in modern sleep, so the Wi-Fi won't be there, but you can have the system clock, RTC and CPU, and there are some other current things can be obtained. But if you use light sleep, so Wi-Fi will be almost in all the cases it will be off, and system clock will be all off for light mode, but RTC will be there and CPU will be in pending mode. Okay, and for deep sleep mode, except RTC, all the things will be in off conditions. Okay. In generally, most of the cases we use only deep sleep mode. So how we need to keep our deep sleep mode? There are two ways are there. Okay, to keep our devices into sleep mode. So one thing is we need to use some predefined libraries or functions are available. Okay, to put you can see to put the ESP8266 sleep mode, use this particular command statement like esp.deep sleep and pass an argument sleep time in microseconds. You need to pass this how much time you need to keep this particular device in deep sleep mode, that you need to mention it is in the um, in this particular deep sleep function. So say suppose uh, like uh, 10 seconds, so you need to mention like 10,000 microseconds. If this are the for that particular time, the board will be in sleep mode. And another thing is, so I don't want to keep my device it into sleep mode for this many time. Okay, so not for a predefined time period. So for that, what we need to do is externally we need to connect some sensor or a button, etc., etc., and you can make that particular device into indefinite period of time. Whenever that particular pin is activated or the button is pressed, then only my device will come back into the functioning state. Okay, got it? So let us see that. So these are the two things for the wake up sources. Okay, right? So here you can see there is a pin is available, GPIO 16 wake up pin. So using this particular wake up pin, we can wake our devices. So as I told you, right, one thing is deep sleep mode with a timer wake up. Okay, so you need to connect this particular GPIO 16 with the reset button or reset pin which is available in this particular board. So the reset pin of this particular ESP8266 will is always high when this particular this particular board is running. So however, when this reset pin receives a low signal, what happened? So the controller will restart. Okay, that is what meant by this reset pin, right? So if you set a deep sleep timer with this ESP 8266, once the timer ends, this GPIO 16, which is nothing but this D not pin, will send a low signal to this particular reset button. So that means that this GPIO 16 or D not, whenever connected to the reset pin, so it will wake this particular ESP 8266 or this particular board after a set of period of time. Okay, so that is the first method to wake this particular device from that particular predefined thing. Okay, so this is the pin which you need to connect, and this is some piece of code. Just you with this is the code which you need to upload. So same thing. Okay, so serial dot println. So this is a deep sleep of 30 E6, nothing but I converted 30 seconds into microseconds. Okay, that's why I wrote it in 30 E6. Okay, so after that my device will be after that predefined amount of time my device will be awake. Okay, right. And the next one is using external wake up. Okay, so you need to connect a button or a sensor to this particular reset button. So whenever that particular button is pressed or activated, so my board or node MCU board will awake. Okay, so this is the code which will looks like. Okay, so which puts that ESP8266 in a deep sleep mode for an indefinite period of time. So for that, what you have to do is you need to just pass a 0 as an argument to this particular deep sleep function. Okay, so this ESP.DSleep0. So nothing but what happens, the ESP will only wake up when something resets the particular board. Okay, so in this case, what we use, we press a button here over here, which fills this reset pin into ground. Okay, so whenever we press this particular push button, okay, this ESP this board will wakes up. Okay, so which does the programming task which are available after this. If you did that, if you write any task, that task will be executed, and then it will goes back to that particular sleep mode until again new reset event is triggered. Okay, so these are the two ways to awake our board, and this is how you need to keep your device into a sleep mode to save that particular power. Okay, so is it clear, guys? Any queries in this particular deep sleep modes? If you have any queries, you can ask me, guys. Is it clear? Online simulation tool is there. I'll tell you. Okay, don't worry about that. Okay, right. So, right, fine. So, I hope you understood. Right, let us go for the next topic, interrupts. Okay, so do you know this particular concept, interrupts? I hope you learned about these interrupts in your programming languages. So if you know, just let me know in the chat box, and try tell me what is this interrupt is all about. So you can reply it in the chat box. Have you learned this interrupts before anytime? So I hope whenever if you go in deep about C languages, error or anything that is stopped. Okay, fine. So right here, can anyone explain me what is this interrupt means? Okay, fine, fine. Right. So let me tell you. Say suppose, right. It is just like an alert. Okay. So generally, this interrupts allows you to detect a change in that particular GPIO state or with that particular state. Okay, without the need to constantly check its current value. Okay, so with nothing but with interrupts, what is if any change is detected, so we can trigger an event or we can call a function. Okay, so that is what an interrupt is. Say suppose we saw a PIR sensor, which is nothing but a motion sensor. So whenever motion is detected, Okay, so we need to turn a buzzer on. Okay, until that particular motion is detected, so we can keep our ESP into some sleep mode. Okay, so that particular, whenever the motion is detected, that is nothing but the interrupt. Okay, so if you carefully observe, like in this particular program, we connected an button over here. Instead of this particular button, you can connect an what we say, motion sensor. Okay, whenever that motion sensor is detected, then you can push that notification to ESP, that particular module, and that awakes that pins, or else in this interrupt will arises. Okay, so here let us see how to create an interrupt. Okay, so this particular, to create an interrupt, what we need to do is we need to call a function which is calling but attach interrupt, and we need to pass an argument, okay, to this particular GPIO interrupt pin, which is nothing but the ISR. That is nothing but we call it as an interrupt service routine function. Okay, and the mode. So the ISR function must be this one. So I catch RAM ATT attribute. So which will be declared, and the mode can be either a changing mode, rising, or a falling mode. Okay. So this is the syntax how you can arise this particular interrupt. So attach interrupt, so digital pin to interrupt. So to which pin you are connecting your that particular input or a sensor or a button, and that ISR function, and we need to select that particular modes. Okay. So let us in me introduce these particular things. So interrupts are useful for making things happen automatically in the microcontroller programs, and can help solving timing problems. Okay, with interrupts, so you don't need to constantly check the current pin values. Whenever a change is detected, that event will be triggered, and this can be happened by using a interrupt service routine function. Okay, so whenever interrupts happens, the process stops the execution of the main program to execute a task, and then get back to the main program. Okay, so maybe you'll be a little bit confused. So let me explain you if with an example. Say suppose you'll go to an ATM machine. Am I right? So to withdraw some amount, right now we are not going much, but previously we used to go. So whenever you enter this particular what we say ATM machine, okay, what happens whenever something is there? You can see something like ads are scrolling on. Am I right? Yes or no? Some ads are scrolling on. So whenever you keep your ATM card, what happens? The ads will be vanished, and you'll get this particular ATM related functionalities. Am I right? So trigger your, insert the pin, enter the password, withdraw all this ATM money withdrawal things related to that particular banking will appear. Once you pull out that particular ATM card, again your ads will be resumed. Am I right? Now, in this particular example, can anyone tell me what is the main program and what is the sub? What is the main program and what is the sub program? You understood the program, the example which I told. What is the main program and what is the sub program? You can reply in the chat box. Yeah. So here the main program is nothing but the ads, and the sub program is nothing but the withdrawal of cash or that related things. So continuously the main program is executing. So whenever an interrupt is nothing but the card. Whenever that is activated, so it will go back to that particular task. That task will be executed, and then after the task is completed, it will comes back to the main program, which is nothing but the scrolling of that particular ads. So that is an example for this particular interrupts. Okay, right? So here how we can use this particular interrupt. Say we can use a function. To set the function, we need to use GPIO interrupt pin we can use. We need, this is the syntax for that particular. So GPIO interrupt pin and ISR mode. This is also function and the mode. So GPIO interrupt pin. So to which pin you are connecting. So for example, GPIO 4, if you are using 14, so you can connect digital pin or pin to interrupt disrupting but 14. So you can use any pin except this 16 pin. Okay. So right. So again, next one is nothing but the function. So the argument which we are passing, that is nothing but interrupt service routine. Okay. So this particular interrupt service routine. So this is the second argument. The name of the function is that will be called every time the interrupt is triggered. Okay. This service routine will be enabled. So the processor gets back to the execution of the main program quickly. Okay. The best approach is to signal the main code that the interrupt has happened using a global variable, and within the loop check and clear the flag. See, this is some extra things how this interrupt service routine will execute. So ISR needs this particular iCatchy RAM attribute, so before the function. Okay. And this, and they having interrupt modes, this is the third argument. So change, falling and rising, you can use any one of this particular mode for that to arise this particular interrupt. Okay. So this is about the interrupts, guys. And the next another functionality which is available here is the timers. Okay. So in general, you know that timer, one timer you already know, which is nothing but the delay. So delay is nothing but it is just like an blocking function. Okay. Say suppose we need to display that particular time in milliseconds. We already seen this particular delay function in our previous programming. And one more timer function is available, which is called the millis. Okay. So here what is this is which returns the number of milliseconds that have passed since the program started. So if you want to calculate like how much time this particular program got started, at that particular time you can use this particular millis. Okay. So why it is that function useful? Because by using some math you can easily verify how much time has passed without blocking your code. So like that you can use this millis. So this is one example. So without using any millis or without delay, if we are using millis. Okay. So first of all we need to mention like LED pin. So generally in the previous program we saw, right, turning an LED, blinking of an LED with some delay statements like delay of 1,000, right? So without using that particular delay, how we can use this particular what we say what without using a delay, using millis, how we can do that particular program. Okay. So here I'm connecting that LED to 26th pin, and here I'm taking a variable which is nothing but LED state and making it as low. Okay. So and here I'm taking one to store the last time LED was updated. So that to store that I'm using a previous millis and I'm making it 0. And I'm taking an interval of 1,000, just like 1,000 milliseconds. So pin mode, you already know about this. So this is the programming part of that particular things. Okay. So here, let me work on this. So here, let's see how this code works. So here, unsigned long current mills. What is the current status of that particular thing for the current time? So it is a reminder, how. Okay, let me go for an if statement. So current millis minus previous millis, which is greater than interval. So what is an interval over here? Like 1,000. So previous millis, which is nothing but 0. We already mentioned. So first of all, if it is, it will check the current millis. What is the current state? So here we use this particular millis. So if it is greater than that particular 1,000, it will execute. Or else what happens? It will stay in this particular condition only. So if it is true, it goes inside and the previous millis will be updated with the current millis, and it will check the LED status. LED will be high or LED will be slow. And if it based on that particular LED state, we can make this particular digital write as a high and low. Okay, got it, guys. So this is how we can use millis, but it looks little complicated for this using this. So generally we use delay statements only, but in some applications we use this millis. So whenever we are using this particular millis, we'll go and search more, explore more on this particular millis. Okay, so this is a statement. Okay, so this is a hardware description about that ESP8266. So is it clear, guys? Understood? Any queries in this? Any queries? Okay, this is a hardware description. Just I want to give you an overview of hardware description of this Node MCU. Right. So here, just a second. Then again, a new version is available. Let me skip that for now. Okay. This is an advantages of using this particular new version. Okay, here. So as I told you previously, see what my next task is that how to use this particular board or how to program it. Okay. Uh, Using our Arduino IDE. Okay, so there are some other platforms are also available, but as we are familiar with this Arduino IDE, so we'll try to use the same IDE for our programming part. Okay, so here whenever you install this particular IDE, okay, you can see only these Arduino boards are available. Okay, initially, you'll see only Arduino boards are available. No other boards are there. Okay, so what you need to do is you need to add these particular boards, external boards or third-party boards like Node MCU boards or some particle boards to this particular IDE. So how to add that? So just you need to go to the boards manager. So here you can see onto your left side, you can see a boards manager is available. In this, you need to just search for ESP8266. Okay. So here these boards are there. So I already installed this. So you can see then install button will be available. So just click on this particular install. Then you can install this particular boards in this tutorial ID. So once you install, you can see the boards in this particular menu. Okay. So let me show you practically in other way. So if you go to tools and the boards, that particular ESP82 board will be added to this particular board manager. Am I right? So initially you'll have only this Arduino, and after installing this 8266, this 8266 board will be added to your boards manager. So whenever this board whenever this board is added, you can use these all boards for your programming. Okay, with this particular package, you can access these many boards. Got it, guys? Right? So this is how you can add this particular board. So here, how to select? So just go to the select board and you need to type right node. Okay, node MCU 1 point for ESP8266. This is the board you need to select. Node MCU 1.0 ESP12E module. So you need to select that particular board. After connecting your board to your laptop, these ports will be enabled. Just select the board and port and then click on OK. And then you can start writing the code and dumping the, you can dump it. Okay. So we'll see this little later. Okay. So this is the one board which I'm gonna introduce you. And we have one more board is available. Okay. Which is nothing but ESP32. Okay. So this is the ESP32 board, which is an next advanced board when you compared with what we say 8266. Okay. So some people will say this is an extension or a successor of 8266. Okay. Okay, 8266 just now we learned, right? So the being having an another more features when compared with 32 sorry 8266 32 having more features when compared with 8266. Okay, new features are available. Okay, this is also from the company called Express If System, and here advantage is having, here you can see, so Wi-Fi is there, Bluetooth option is also there for wireless capability, and it is also having a dual core processor. Okay, so this is also from Expressive Systems. Okay, and that's why we call it as ESP. Okay, and this is a 32, that is a series name. Okay, ESP32. Okay, and just like the same thing, so why it is popular, it is low cost, low power, Wi-Fi capabilities are there, same like 8266, but with some more advantages like Bluetooth is also available, dual core is there. So like two Extensia 32-bit processor are available. So we call them as a core 0 and core 1. So that's why two different dual core processors are available for this 32. And also we are having a rich peripheral of input and output interference. Okay, you can connect ADCs, DACs are there, UART, SPI, much more are available. GPIO pins are available, and also it is compatible with, just like 8266, you can, it is compatible with Arduino programming language and also micro Python. Okay, so these are the specifications of this particular ESP32. Okay, this is also a Wi-Fi chip. Okay, and you can see here the wireless capability is up to 150 Mbps. Okay, and Bluetooth, two Bluetooths are available over here. Okay, so like BLE and Bluetooth Classic. Okay, two Bluetooths are available. And as I told you, right, two Excelta is there. One is running at 160 and another one is running at 240 things. So these are the memory things. ROM, RAM, and SRAM is available. Okay, and there are some other options are also there in this particular 32. Okay, so low power, and also I told you, right, there are rich peripheral of input output, and there is security features are also there which are available. So this is the functional block. Okay, some more advanced features are there. Cryptographic hardware accelerations can be used. Okay, core and memory, Bluetooth thing are there, radio things are there. So these are the few features. If you want to go in deep, you can get the data sheet from what we say online. Okay, so the similar way how we used our IDE, Arduino IDE to dump this board. Similarly, you can do so. Open your IDE, go to your boards manager, and search for ESP32. And there are two types of boards are there, like Arduino ESP boards and expressive systems. So I recommend you to install this expressive system. So there is an update is available, so you can update it. Okay, so just install that, then like install option is available, just install. Once it is successfully installed, you can see the boards will be available. These are the different boards from that particular package which are available. So you can select that particular board in the boards, like node 32. So this is the board generally we used. Okay, so we'll see that little later. Okay, fine. After that you can write the programming part. Okay, this is about how you can what we say, connect your board to your Arduino IDE. Is it clear, guys? Any queries? Okay, right, thank you. Okay, there are, let us work on this particular what we say features. What are the features are available? So this is a pinout diagram. You can see all pins can be used for GPIO things. Okay, for few pins are there where we can use only for inputs. So these are the other functionalities of that particular pins. Okay, so I recommend whenever you are developing any projects, you can go for ESP32 rather than 8266, because this is the latest one with some more features. Okay, and ADC is available. Okay, PWM pins are can also be used. Okay, we already seen this in our last thing. Okay, and interrupts is also available in this particular ESP32. It's the same method. So you can use any one of these particular pins for that interrupt. Okay, so there are three modes are available in this what we say in 8266, but here there are five modes are available for interrupt. Timers are available, delay, millis, okay, which we already discussed it before. And ESP32 deep sleep modes, just like 8266, we have deep sleep modes. But here we have five different types of power modes are available. Okay, so in the previous we saw like modem, light, and deep. But here we see like active mode, modern sleep mode, light sleep mode, deep sleep mode, and hibernation mode. So two extra modes are added for that 8266, active mode and hibernation mode. Okay. So here are the comparison of that modes. So why we need? So we already discussed that. So RTC GPIO modes, wake up sources. These are the wake up sources are the timer mode. Touch pins are available. So here in this particular, whenever you see this diagram, you can see some touch pins are available. Okay, like here you can see touch pins. Okay, using this particular touch pins, you can wake your devices, and also there are some external wake ups are there. Okay, and also you can use ULP co-processor to wake your hour. These are the different options, are ways to wake up our device. Okay. Uh, right. That's it about the hardware description of these both modules. Is it clear? Any queries in this hardware description? Okay. If you have any queries, you can ask me in the chat box. I'll try to clear that. You can ask me in the chat box, guys. If you have any queries in this. How to give pin number? So just write the number. That's it. Don't write GPIO or D1 or like that. Just write the number 1, 2, 3, 4, 16 like that. You need to add. That's it. Okay, right. So fine. How to use the LoRaWAN and NRP. I'll so in our coming sessions we have this particular communication. How to use that at that particular time. I'll explain you this. Okay, and so if you have an idea about the IoT architecture, if you remember, till now we saw uh, like uh, like a first layer, perspection layer, physical devices layer. Till now, we choose that particular things. Right, what I mean to say, like the first layer we completed, like how to collect the data. Okay, so in the second layer comes about the connectivity layer. So to transfer the data. So for that we need to use this boards. Okay, we'll see how to use, how to connect that. Okay, using Bluetooth, etc., etc. We use that. Okay. And for this particular module, we can explore that particular next layers, connectivity layer, uploading the layers. Okay. So how to choose the boards? So it depends upon your application and requirements, guys. Okay. So you need to just search. First of all, you need to have a complete idea of your application, and then you need to choose the boards. Okay. I recommend 32 is good when compared with uh, other 8266. Okay. So for people, right from today onwards, I'll work on hardware only. Okay, I won't use any simulator. Okay, but I many of you doesn't have this particular hardware with you, so you can use some simulator. Let me show you the simulator. Okay, so there you can explore all those stuff. Okay, so that is what we call it as a walk V. Okay. So this is a simulator for ESP32 WOKV, world's most advanced ESP32 simulator. So this is a WOKV, and if you open that, so you can use Arduino Uno, ESP32, STM32, Pico, PiPico. You can use these boards as a simulator. Okay, but it's not that much user friendly like Tinkercad, but you can work on this particular boards, guys. Okay, so if you go for ESP32, so there are some defined predefined things are there. Okay, so as I told you right there in ESP32 also there are some other boards are available like S2, S3, C3, C6, H2. Okay, box 3. So these are the boards are available. So depending upon your things, so you can choose that particular thing. So say suppose if you having a basic board ESP32, you can go for this particular board. Okay, so you can see to your left side you can write the coding part. Okay, and to your right side you can see this particular board, and if there is an plus mark is there, click on that, and all your components are available. So you can take any component, just a basic like LED. So like LED, connect it. Okay, and join anode and cathode. So to your board, it's just like that how we connected in our boards. Just you can connect that cathode to ground. So I'm just randomly connecting it. Okay, then you can write the programming part over here. So okay, so you can sign it up and you can work it. So this is a start simulation. So you can see that there is a predefined code is available like serial begin serial dot println. Okay, so you can see that is printed over here. Okay, so just like that, you can do all those stuffs. This is a serial monitor for your information. This is the serial monitor. Okay, so this is using C++ diagram. Okay, this is a JSON for file, and this is a library managers. As this is a basic, there is no libraries are available. And also this is basic C, and also there are some Python, micro Python projects are also available over here. You can use that particular micro Python. Okay, yes, you can see here. Micro Python code are also available. So as I told you, right, you can use Arduino programming or else micro Python to develop your projects. So for that, you can go through that micro Python and you can work on it. Okay, so I guess this is a micro Python. Yeah, right. This is the micro Python code. Okay, then you can see this. Okay, you can work on this, but right now my intention is I want to show you hardware. Okay, so right, just give me 2 minutes. I'll use it. I'll show you the hardware. Okay, right then. So I brought my module. So first of all, let me connect it. I have ESP32 board. Okay. So first of all, after connecting your board, we have a cable. USB cable is there that we need to connect to our ESP32. And then after connecting your board, so first step is you need, as I already told you, you need to go to the boards manager. You need to install this first. That is the first step. And the second step is, okay, that is the mandatory step you need to do, prerequisite. And the next one is you need to select the board and the port. Okay. So for that, just click on this particular white and click on select other board and the port. Okay. So here you need to search for node 32S. Okay. We have ESP32S with me. So here, so node 32S, select that particular board, and also you can see port is enabled. So let me remove it. So I'm disconnecting the port. You can see there are no ports are available over here. Okay. So whenever you connect your board to this particular, to your laptop, this serial port will be enabled. So you can see COM8 serial port USB. So the COM number, it is not specific, or it is not same for all the laptops. It might differ. Okay. So for me it is comet. So you need to select the board and you need to select the port. You need to select the board and the port and then click on OK. Okay. So in some cases, a few people will get more ports over here, com ports. So how to check that? So for that you need to go to device manager, and here you can see an ports option is there. So this is a port option. So Silicon Labs 6P210X USB to UART bridge. So you can see over here. So this port, uh, you can see to which port. If you disconnect your board, you can't see that. So the ports is option is completely disabled. But whenever you are connecting it, that ports will be enabled. So for me, I only connected this particular board. That's why only port is enabled. So in some cases, for few laptops, whenever you are working, so even you won't see these particular ports where even though you connect it. So at that particular time, you need to install some drivers. So for that, what drivers you need to go is CP210X drivers. Okay. So you need to install this particular driver. So go to the Silicon Labs. Okay. And go to downloads. Go to downloads. Silicon Labs. Go to downloads. There you need to install this Windows driver CP210X Windows drivers. Don't install universal drive Windows driver. Just install this Windows drivers. Okay. So after installing this Windows drivers, you can see this particular port. Okay. In some cases, for few laptops, this port will be in disabled mode. So you need to install this particular drivers. Okay. Right. So is it clear, guys? Yeah. Tell me. Someone is calling me, sir. So any alternate for Voc V? So Voc V is a best one for all the cases. And in some there is a thing called renode, I guess a renode or QME. So some other things are Proteus is also available, but that is not recommended. Renode is also a good one. Proteus is there for few limited access are there, but Vokvi is the best one for all the other for all functionalities. Okay. Is it clear, guys? Any queries? Okay. So let me write a piece of code and let me show you how to write a code in this as we are using this IDE for the first time in our classes. Okay. Right. So here, first of all, what you have to do is you need to download that particular pinout diagram. Okay. So I already downloaded it. So this is the pinout diagram. Okay, so whenever you are writing any code, so you need to download this pinout diagram because we need to know, right? So to which pinout we are writing, to which pin we are writing the code. Okay, so for that we have an pinout. We need to download this diagram so that we while checking we can use this particular pin. Okay, right. Got it? So let me write the coding part. So here to this particular pin, there is an inbuilt LED is available. Okay. In Arduino also we have an inbuilt LED. Okay, like 13th pin. So here also we have an inbuilt LED is available on this particular board. So we try to use that particular LED. We try to blink that particular LED. Okay. So for that, let me write the code. So here, as define. Okay. So first step, don't get confused. First step, what we have to do is we need to select the board and select the COM port before writing the code. Okay. So after that, this is a white space for writing the code. We need to write that. Okay. So as define. So LED underscore built in. Okay. I'm using that for a proper understanding. So here there is a GPIO2 is available for a built-in LED. Here it is not. This is a GPIO2. So this particular D2 pin. So this to this D2 we have an LED is directly connected to that. We are accessing that. Okay. And after that, pin mode just the same way how we used, right? So like LED underscore built in. Okay, so that is an pin, and the status is nothing but output. So this pin is an output, right? So output. So I want to blink that particular LED. So what I need to do? So digital write off. What is that pin? Pin LED underscore built in, and it should be high. Am I right? And I'm giving some delay of say suppose 1000, which is nothing but 1 second. And also I want to make it off, right? So digital write off LED underscore built in comma low. Okay, and delay of 1000. So this is a sample program which we already seen, right? Yes or no? Okay, so after writing the code, what you need to do? We need to compile the code, right? So there is an option is available on the top, tick mark. So this is to verify whether our code is right or not. So just click on this particular verify. A pop-up output window will be popped up. Okay, so if there are any errors, syntax errors, that will be displayed in this particular output screen. Okay. You can see done compiling over here. A message is popped up over here, done compiling, and you can see the sketch uses 2 lakhs bytes. 90% of program space is used. Okay, so there are some description over here. After successful, what we say, uh, verifying, what you need to upload. So there is an beside this particular verify option, there is an arrow mark is there to upload the code. Just click on this particular upload. Okay, so again it will compile. So before uploading, so it will compile, and you can see done compiling and the code is uploading. Okay, so done uploading, and then you can see your LED will be inbuilt LED will be blinking. Okay, understood, guys? So this is how you can connect the thing. So let me explain you one more time. Okay, so after writing the code, what you have to do is you need to verify the code. Okay, before that, let me cancel this. Before that, you need to select the board and the port. So select the output screen, then select the 32S, select the board, and select the COM port. Okay, and verify it. So click on verify. Click on verify. Okay, done compiling, and then click on upload option. Click on upload option. So done uploading. So the code is uploading. Right. So let me show you the output. So I'm turning my video on. So you can see the output over here. Is it visible, guys? Okay, right. Uh, I guess you can't see it. Just a second. Here, this is an output. You can see one green red light is there. That is red light is nothing but the power light. And you can see beside that there is one more light is available. White is available. That is blinking. You can see. Yes or no? If you see, can you tell me? Okay. So that is LED is blinking. Got it? Right. So like that, you can control your inbuilt LED. Okay, right? So now we'll start some more applications, how to write, how to use all the stuff. Okay. Uh, right. So let me write a few more things. So we'll see the serial monitor, which is available over here. Okay. So the serial monitor, let's see that. Okay. So here in this, let me for how to enable my serial monitor, we have a statement called serial dot begin. Am I right? So you can, this is a default baud rate. We already discussed this 9600. And here, let me write the same thing. So digital write. So here, serial dot print ln. Okay, let me writing some LED is on. Okay, I'm just writing some statements. LED is on. Okay. Similarly, I'm writing one more statement. The serial dot print ln. So LED is off. Okay. Just I'm writing this to explore the serial monitor. Okay. So once you selected one, by default the same board will, didn't disconnected it, right? So the same board will be selected in the COM port, but after removing it and reconnecting, after reconnection also, you will find the same stuff. It will automatically connects to that. Okay, until you change the board or until you change the port. Okay, fine. And so here, after writing, what we need to do, we need to compile the code. So compile the sketch. So you can see done compiling, 20% of program space is used. I recommend you to keep an eye on this particular program space. Okay, because in general, if you want, some people will develop, write a little large code, the program space will be not sufficient for that. Okay, so please keep an eye on this particular program space. Okay, once the compiling it done, what we have to do, we need to upload the code. Just upload the code. Click on upload the code. So it is the uploading. Okay, you can see done uploading. Okay, so here to open your serial monitor, what you have to do is, to your left side you can see there are two options are there. One is serial plotter and another one is serial monitor. Okay, so you need to just click on that particular serial monitor. Okay, you can see here there are some random things are coming, which is not, we can't understand why. Because to your left side, you can see there is a board 115200 board. Okay, so this is a board rate. But here we mentioned in the program like 9600. But in the serial monitor, you can see the baud rate is 115220, which is not the same. So what you need to do is, you need to click on this particular board and you need to select that 9600 baud rate. Okay, and you can see the statements are displaying it. So the serial, in the serial monitor, and you need to select the same baud rate what which you wrote in your programming. So the both should match. If you keep some other baud rate, you won't see the data. Okay, you can see here. We can see that, including the timestamp. If you want, you can click on and disable the timestamp, which is above this particular baud rate timestamp. So the same display will be for every second, but the data will be displayed. Understood, guys? Clear with this? Any other queries in this programming part? Just and for your understanding, I wrote all this stuff. clear? If you have any queries, you can push it in the chat box. And one more thing, it is keep on running, guys. Okay, until you unplug your module from the laptop, it will keep on running. Okay, you can't stop it by using anything. Okay, right? If you want to stop the code, you need to unplug it from your laptop. Then you can see not connected and it will stop. Okay, that is the only method. One of method to disconnect the programming. So once you connect it back, the same code which is dumped in that particular board will be executed again. You can see now it resumed. Got it, guys? Right? So no need to redump the same code multiple times. Got it? Any queries? You can ask me in the chat box. Let me introduce one module, which is nothing but an IR sensor. Okay. So I integrating some sensor. So let us work on it. Okay. So here, let me show you what is IR sensor for your understanding. So IR sensor. So this is the sensor which I have with me. Okay. You can see this is IR sensor. Okay. So generally this IR sensor will be used to detect any object, just an object. Okay, if you find any object is there, okay, it will detect. Okay, so this is a module. We have an IR LED and a transmitter and a receiver. The transmitter just transmits some signal and the receiver will receive it. This is not, IR sensor is not for what you say, distance calculation. This is only to check whether any object is there or not. Okay, for object detection. So on that we have a power LED and an obstruct LED. Whenever any obstruct is there, the LED will be on. And here there is a potentiometer is available for the distance. Okay, you can increase the distance adjustment that can be done using this particular potentiometer. And if you carefully observe, um, all right, I don't have that particular image, I guess. I don't have an image. So generally it is having a 3-pin sensor. It is a 3-pin sensor, 3 terminal. What VCC, ground, and output. These are the three pins are available. So just may open it for you. Okay, this is a 3-pin. You can see here. This is a 3-pin. One is out, ground, and VCC. Okay, so the potentiometer might be a little bit different. You can see here out, ground, and VCC. Okay, so for VCC we need to give sufficient voltage, and ground we need to connect, and out is nothing but this is a D out. This is a digital pin, just yes or no condition that we need to connect to any one of the GPIO pin. Got it, guys? So let me go back to this. Okay, how to save, just a normal um, thing, guys. So you can save it like a Control S. You can save it. Okay. So let me open a new sketch. So for new sketch, just use a shortcut key like Control N. Okay. Right. Fine. So first of all, you need to select the board. So you can see I disconnected. So you can't see my port. Let me connect back. Okay. So now you can see port is enabled. So need to select the board, which is nothing but Node 32S. Okay, right. First of all, let me write the coding part. It is very simple, nothing much complicated. So Ash define. So IR, let me connect to, let me check to which pin we connected. So these are the different pins are available. So let us go for GPIO 21. Okay. Anything is, you can choose any one, guys. Okay. So let me choose 21 or 16, 14, anything is fine. So let me use, okay, okay, just a second. It's like 17, 16. Okay, anything. So let me use 16. Okay, anything is fine, guys. Okay, 16, right? So we need to mention over 16, not GPIO or D. Okay, just you need to write 16. Okay, and like pin mode. Okay, I'm writing the same code in the previous one, guys. Okay, okay, little extension like so. Ash define IR, I connect it to 16. Okay, so pin mode is there. So pin mode. So IR is an input or output? It is an input component. Okay, so here let me write that. Okay, if, okay, so digital read of IR, if it is double equal to 0. Okay, so what I need to do, let me write these statements over here. Okay, okay, so inbuilt LED will be high, and here let me write like object is detected. Okay, and give a delay of 1000. Okay, right, else. Okay, make this, I'll copy this and paste it over here. Right, and here let me write no object is detected. Okay, okay, let me check either it is 0 or 1. Okay, we need to check that. Okay, and let me remove it, this delay statement. Got it? The simple thing. Okay, so first what you need after writing the code, I hope you understood what we wrote over here. So LED built in, we are taking that inbuilt LED and I connecting IR sensors to 16, and pin mode is output and input, and this is that IR sensor. We write a condition, if it is detected, that LED will be on, and at the same time will display like object is detected, else we are writing this particular things. Okay, just verify the code first. We need to verify. Okay, now successfully verified, no errors are there. Click on dump or upload. Okay, successfully code was uploaded. Okay, so let me connect the hardware first. I didn't connected any hardware. Okay, just a second. Let me connect the hardware. So VCC and ground, the VCC of this particular IR sensor, we need to connect it to 5 volts or 3.3 volts which is available. We need to connect to that. Okay, first, and then ground pin you need to connect to ground. Yes, and then we need to connect the GPIO. Okay, so I'm connecting output pin of IR sensor to, we connected it to 16, right? So connect to 16. Okay, so let's check the serial monitor. So object is detected. Okay, because my sensor is having detected. Got it, guys? Like that, you'll get an output. Understood? Understood, guys? So object is detected. So you can see, and here again, right? Object is detected all the time. Okay, because my sensor is detecting that. So this is how you can use that particular IR sensor. Someone is asking what happened if pin mode is not mentioned. You can check it, guys. Okay. Is it clear? Any queries in this? Any queries? So if you have any queries, you can ask me in the chat box. Okay, this is a simple program. Okay, fine. So in tomorrow's session, we'll try to see some more concepts. I'll try to introduce an ultrasonic sensor or DHT. Some sensors are there. I'll try to use that. Okay, and we'll see. We'll explore all those applications. Okay. Uh, you can ask your queries, any queries if you have here in the chat box. Okay, fine. You can ask. So all your queries will be answered here, guys. Okay. Okay. Just check. Just you can combine it. So all the setup codes can be written in one setup code. All the loops will be all the loop code can be written in a single loop code, and just make sure that you need to keep an eye on that particular program space. Okay, as we already seen, and depending upon the logic, you need to mention. You have an idea, right, about that particular logic. It will work for sure. Just keep an eye on program space. That's it. So any more queries? So in our next sessions, we'll try to discuss about how to connect this board with Bluetooth, okay, or how to connect with some mobile applications like so WhatsApp or what we say Telegram. That's we try to see it in our coming sessions. So if you regularly attend that, you can explore all those stuff. Okay. So that's it for today, guys. I hope you enjoyed this today's session, and tomorrow we'll see uh, some more hardware components, interfacing, and etc. Got it, guys? So, if you don't have any queries, let us close this session.